Okay, in this video, we're going to take a look at how to use the power-reducing formulas to simplify trigonometric expressions that involve a trig function that's raised to a power, such as 2 or 4 or even 6. So my first example is 10 times the cosine to the fourth power of x. Now, I've selected some of the more difficult problems that you were given in the assignment so that hopefully you can get a better understanding of it. You will have access to the formulas, and so please don't try to memorize these. Even when you get to a calculus course, you're going to have access to the formulas. We're using the power reducing formulas, okay? And we're starting with a problem related to cosine. So I'm going to transfer this formula over to my screen so we'll have it. So the first problem we're dealing with deals with cosine, and the formula that we have is the cosine squared x equals 1 plus the cosine of 2x all over 2. Okay, so that's the formula we're going to use for this first particular problem. And notice that it's cosine to the fourth, but the formula is cosine squared. So the first thing I have to realize is that I have to rewrite my problem to become 10 times the cosine squared of x, and that quantity is squared. Remember the rule that if you have power to a power, you multiply the exponents. So I'm kind of using that formula in reverse. I can then use the process of substitution to substitute the cosine squared x power reducing formula into this problem, which is what we're going to do. Okay, so you have to keep the 10 is still part of the problem. Okay, so you have the 10 on the outside. I'm going to replace the cosine squared x with the formula. Okay, so I would have 1 plus the cosine of 2 times my variable, which is x, all over 2. And then I have to actually do some basic algebra in order to simplify this problem. You need to remember you have to square this. So we're going to have 10 times, you might want to put the 10 over 1 since you have a fraction, 1 plus cosine of 2x all over 2 times 1 plus cosine 2x all over 2. You have to remember that you got to multiply that expression times itself. And to do that, we're going to use good old basic FOIL. Okay, so the 10 over 1 is still on the outside. Going to hang out. Okay, I'm going to go ahead and do the denominators. 2 times 2 is 4. Then for the numerators, I'm going to use FOIL. So I'm going to do 1 times 1, which is 1. 1 times the cosine of 2x is plus cosine 2x. Then I do cosine 2x times 1. So I have plus cosine 2x. And then finally, cosine 2x times cosine 2x is cosine squared 2x. And again, at that point, I'm going to do some good old basic algebra, and I'm going to combine like terms. So I have 10 over 1, 1 plus cosine 2x plus cosine 2x is 2 cosine 2x plus cosine squared 2x, and that's all over 4. Okay, then I'm going to distribute the 10. Okay, one little step at a time. It may help you to use like colored pencils. You see that I'm doing it in color, so that may help you. So I'm going to distribute the 10. 10 times 1 is 10 plus 10 times 2 cosine 2x is 20 cosine 2x. 10 times cosine squared 2x is 10 cosine squared 2x. And that whole thing is over 4. Now, that really means each individual piece is over 4. So if I look at them individually, and I'm going to try to squeeze that in right here, I would have 10 over 4 plus 20 cosine 2x all divided by 4 plus 10 cosine squared 2x all over 4. And then I'm going to do some good old basic simplification. Okay, at that point we have 5 over 2. Remember, 10 divided by 2 is 5. 4 divided by 2 is 2. 20 divided by 4 would give me 5 times the cosine of 2x plus 10 divided by 2 is 5. 4 divided by 2 is 2. So I have plus 5 halves times the cosine squared 2x. Now, at that point, you might think, well, oh, I'm finished. But guys, you're really not finished because you're trying to get rid of the exponent on your trig function. And this last term here still has a squared term. Okay, and so we have to fix that. We're not finished because, again, this last term here, 5 halves times the cosine squared of 2x, you still have an exponent, and we're trying to get rid of the exponents. Okay, so we're going to have to use our power reducing formula a second time on that particular piece. So that does mean, though, that the 5 halves is going to stay, plus 5 cosine 2x is going to stay, plus 5 halves times, and in place of cosine squared, we're going to substitute the formula again, okay, which would be 1 plus cosine of 2 times your variable, but our variable now is 2x over 2. I just did a direct substitution of the formula that we had at the top of the page, okay, that we started with, okay, into that problem, or in place of cosine squared. All right, so now, let me get back down there. Okay, now, again, all the stuff at the beginning is going to kind of stay there with us. Okay, so that we have 5 halves plus 5 cosine 2x plus 5 halves times 1 plus cosine 2 times 2x is 4x all over 2. Okay, and then we have to come back and basically, again, at this point, do a little bit of algebra. I'm going to distribute the 5 halves, okay, so that we have, let's see, 5 halves plus 5 times the cosine of 2x. 5 times 1 would give me 5. 5 times cosine 4x would give me plus 5 cosine 4x, and then in the denominator 2 times 2, so this whole thing would be over 4. And then I'm going to break it apart so that we have 5 halves plus 5 cosine 2x Okay, so I have 5/2 plus 5 cosine 2x plus, we're going to have 5 over 4 plus 5 over 4 cosine 4x. And I'm almost home free because as I look across that problem, I now no longer have any exponents on the variables, which is a good thing, okay? And the only thing that I notice that I need to do is I have 5/4 and 5/2, and I need to combine those like terms. Well, remember, 5/2 would be 10/4. So I have 10/4 plus 5/4, which would be 15/4, plus 5 times the cosine of 2x plus 5/4 times the cosine of 4x. Now that is ultimately the final answer. And again, the deal is I know I'm finished because I no longer have any exponents on my trigonometric function, which in this case was cosine. All right, let's look at another one. This particular problem involves sine, and again, I picked one of the more challenging problems. We have 22 sine to the 4th x. And again, I have to realize, first of all, I probably need to go and find my formula for sine. So my sine squared formula, my power reducing formula for sine squared is sine squared of x equals 1 minus the cosine of 2x all over 2. And again, I do have to realize here that this is sine to the 4th, and I'm looking for sine squared, or my formula involves sine squared. So again, I have to realize that I may have to do some manipulation here. So I have 22 sine squared of x quantity squared. And so again, at that point, I realize, oh, I can do a direct substitution of my power reducing formula into my equation. Okay, so we're going to first do our direct substitution. And again, I'm trying to color code it for you guys. So we would have 22 times, and in place of sine squared x, I'm going to put my power reducing formula, 1 minus the cosine of 2 times the variable. The variable happens to be plain old x, all over 2. And then it becomes, a little bit of algebra work, okay, because then we have to, again, remember that to do that, you're going to need to do 22 over 1 times 1 minus cosine of 2x all over 2 times 1 minus cosine of 2x all over 2. And so the 22 is going to kind of hang out front for a few minutes. I can multiply. Let's see, we would have 22 over 1 times, I'm going to multiply the denominators together. 2 times 2 is 4. In the numerators, we're going to use full again. 1 times 1 is 1. 1 times minus cosine 2x is minus cosine 2x. Minus cosine 2x times 1 is minus cosine 2x. Minus cosine 2x times minus cosine 2x. Be careful, that's positive cosine squared 2x. Okay, then we can multiply through by the 22. Okay, do that. Well, let's combine like terms first. Okay, we can combine together minus cosine 2x and minus cosine 2x. So we have 22 over 1 times 1 minus 2 cosine 2x plus cosine squared 2x all over 4. Okay. Then I'm going to distribute the 22. Okay, so I would have, let's see, 22. Whoops, sorry about that. We would have 22 minus 44 cosine 2x plus 22 cosine squared 2x. And again, that whole thing's over 4. I'm going to go ahead and put each individual piece over 4. Okay, so that we can do some simplification here. So we have 22 over 4, which would simplify to 11 over 2, minus 4 goes into 44 11 times, so it's minus 11 cosine 2x plus 11 over 2 times the cosine squared of 2x. And again, at that point, you may think that you're finished. But guys, remember, the goal is to get rid of the exponents on the trig functions. And we haven't finalized or finished that because this last term here still has the squared term in it. So we're actually going to have to do the process again on 11 halves cosine squared 2x. But now, instead of the sine formula, which we started with, we need the cosine. So remember that the cosine squared x formula is 1 plus cosine of 2x all over 2. Okay, so remember, all the other pieces are still going to kind of stay the same, and they're going to tag along with us. So we're going to have 11 over 2 minus 11 cosine 2x plus 11 over 2 times, and I'm going to use my cosine squared power reducing formula. So I'd have 1 plus the cosine of 2 times my variable. My variable is 2x all over 2. And then I'm going to do the simplification so that I have 11 halves So I have 11 halves minus 11 cosine 2x plus 11 halves times 1 plus cosine of 4x. 2 times 2x is 4x all over 2. Okay, then I'm going to distribute the 11 halves. Okay, so I have 11 halves minus 11 cosine 2x. Get this out of the way. Okay, so I have 11 halves minus 11 cosine of 2x plus 11 times 1 is 11, 11 cosine 4x all over 4. So if I break that apart, okay, I would have 11 halves minus 11 cosine 2x plus 11 fourths plus 11 fourths times the cosine of 4x. And I am almost home free because, again, at this point, notice I don't have any exponents on the trig functions, but I do have some like terms. I need to put together my 11 fourths and 11 pi halves. You always want to combine, or 11 pi halves, 11 halves. You always want to combine together your like terms whenever you can. So we have 11 halves plus 11 fourths. So this would be 22 fourths plus 11 fourths is 33 fourths minus 11 times the cosine of 2x plus 11 fourths times the cosine of 4x. And that's actually your final answer. Again, you have gotten rid of any exponent that you had. So I hope you find this helpful as you try to think about how to use the power reducing formula.